Hey everyone, if you're watching this, it is November 5th and 6th and you are home. I felt like we needed a little more time to talk about ratios, rates, and especially unit rate and unit price. So this video is going to be just kind of recapping what you maybe started the week with. If you were home, you're going to get to do the lesson in person. And if you started the week here with me, you're going to be working at home a little more. I think we need a little more time to make sure we have this topic down before we go any further into this unit. So number one says, to make the color rose, you mix drops of food coloring. You use 5 drops of red, 1 drop of blue, and 2 drops of yellow. What is the ratio of yellow drops to the total number of drops written in simplest form? So let's kind of come back to this vocab word ratio. So we know a ratio can be part to part to total, or total to part, and we write them 3 ways, right? We can write them as a fraction, we can write a ratio with a colon, or we can use the word to. So I used A and B to show a generic amount instead of numbers. So this ratio is asking for yellow to the total number of drops. So yellow over total is how I'm going to set up my fraction. I'm just doing that so that I know what my comparison is. So if I look back through my information, yellow, if I follow back through, is 2. And then my total, so 5 plus 1 is 6, plus 2 more is 8. All right, let's make sure I've completed this task. What is the ratio of yellow to total written in simplest form? So is 2/8 written in simplest form? Well, hopefully you know they're both even, so you can reduce by 2. And if you reduce by 2, now I'm going to check on my calculator, and I'm going to only do that just to show you how to do it again. 2 ABC 8. If you plug that in and hit equals, it will reduce it for you, which is what I would have gotten if I just reduced it on paper. So 1 to 4 is my ratio. Now I could write it as 1 to 4, 1 colon 4, or 1 over 4. All those are a way to express yellow to total to make the color we want. Now 1B says, how many drops of each color will you need to use if you use 24 drops of food coloring in all? All right, well, we know there's how many drops total. If we come back up, we have that information already, right? So right now, we're saying there's 8 drops total in the recipe we were using. But they're saying they want to make it bigger and have 24 drops in all. So if I bring down my yellow to total, I had 2 to 8. And they're saying we don't want 8 in our recipe anymore. We want to bump this up, just like in facts class. We're going to now have 24. So remember that equivalent ratio? So if I'm making an equivalent ratio, I'm going to think 8 times what will give me 24? 8 times 3. So now I've got to do the same to my numerator. So 2 times 3 gives me 6. So I need 6 yellow drops, right? Now let's look at my other colors. So I've got red is, if I look back up in the problem, 5. And then red to total. Well, remember the total number was 8 in that recipe. Okay, I don't want 8 anymore. I want 24. So again, what am I multiplying 8 by to get 24? 8 times 3. So I've got to multiply in my numerator. 5 times 3. 5 times 3 gives me 15, and that is red. I've got one more color left, right? My last color is blue to total. And if I come back up and look at the top, I've got 1 drop of blue to 8 total. I want to take and use 24 drops. So my new denominator, is 24. I'm multiplying by 3 on the bottom. So I've got to multiply by 3 on the top, or my numerator. And that would give me 3, and that's blue. So the question says, how many drops of each color? So I've got 6 yellow. I'm going to make that a nice Y here so it's obvious. 15 red, and 3 blue. Now I'm going to double check and make sure I added this correctly, or did any of my computations correctly by adding these together, because what should they add up to? You said 24, you're correct. So 6 plus 15 is 21, plus 3 is 24. So that double checks. It's always good to go back and check your work, make sure you didn't make any mistakes. Now, I set it up as two equivalent ratios or two equivalent fractions, which make a proportion. So that was another vocab word we talked about the other day. All right, let's take a look at number 2. Are these two ratios proportional? So in this case, I've given you a set of fractions, okay, and we can call them ratios, right, of 5 to 8 and 10 to 15. And you're going to tell me if they're proportional, which means can I stick an equal sign here, or is it going to be a not equal sign? So let's think about two ways that we talked about the other day to do this. One is you could reduce your fraction, okay? So I could reduce 10 over 15. 5/8 is already in simplest form. The only factor that they share is a 1. So in this case, I can reduce by 5, and that gives me 2/3. So one way is to reduce. 2/3 is not equal to 5/8. So I know I can go back and put that not an equal sign there. I could also do my cross products. 15 times 5 is 75, and 10 times 8 is 80. So that's definitely going to be a no. So now you've got two ways. You kind of have to decide what way you're more comfortable with. So again, I can reduce this fraction, or I could do my cross products. 12 and 12. So I know they're equal. I can circle yes. All right, let's look at this last one. Now, 36 and 49 are kind of large to do my cross products. I would need my calculator. So what I'm going to do is I'm going to look to see 6 times something, does that give me 36? So I could reduce this, but right now I'm going to look to see, can I scale up? And I can if I multiply by 6. So 6 times 6 is 36. All right. Is 7 times 6 49, though? In this case, no, it is not. It should be 42. So that's a no. So that would be a not equal sign in there. So they're just two ratios, but they're not equivalent. Let's look at number 4. I brought this question back because a lot of you kind of struggled with it the first time, and I'm curious if the second time you're able to do it on your own. So at this point, if you want to pause your video and read the question, see if you can do it, you're welcome to do that. If you want to just stay and work with me, you're welcome to. An art teacher mixes 54 ounces of yellow paint and 24 ounces of red paint. How many ounces of yellow paint would she need to mix with 32 ounces of red paint to maintain the same proportion? So there's that word proportion, right? So we know a proportion is two equal ratios. So let's come back through and see what we're comparing. The quantities we're comparing are yellow to red. And the first batch that she mixes is 54 ounces of yellow to 24 ounces of red. And it says that she wants to then make a batch that has 32 ounces of red. So I'm going to come down here, 32 ounces, because red is in the denominator. I'm going to make sure I put it in the bottom. How many ounces of yellow? So I put yellow on top in the numerator, and I kind of have nothing up here right now, which is good because I'm going to find that. Now, 24 doesn't go into 32 evenly. So there's a couple things that we talked about last time. Some of you had some different methods on how you wanted to do this, and that's totally fine. One method was we took the 54 over 24 and we reduced it. And I can actually reduce it by 6. And I get 9 over 4. So that's the simplest form of this fraction. So I'm going to use that, 9 over 4, and see if I can plug that into the proportion, if it's going to work a little easier. Well, let's look. Does 4 go into 32 evenly? It does, right? So I'm working with the numbers that are compatible, right? 4 times 8 gives me 32. So now I've got to do that to my numerator. 9 times 8 is 72. So here's a way to check. Some people are a little skeptical and say, I don't know if that works. Do your cross products and see if they work. So 54 times 32. So that gave me 1728. Now I'm going to try 72 times 24. 1728. Notice I have the same cross products, so my cross multiplication was the same. So it does work. So remember, ratios can be written in simplest form. And use your simplest form to help you find a compatible number, right? I knew 24 didn't go into 32 evenly, but if I reduced it, 4 did go in evenly, and it went in 8 times. So that was much easier. So when it says how many ounces of yellow paint, it's going to be 72 ounces of yellow. Okay, now you might have come up with this answer a different method, and that's okay, based on what we did in class on Monday. All right, let's take a look at number 5. Number 5 said, a bean plant grew 8 feet in 3 days. So right there, we know we have a rate of feet per days. Okay, we have 2 different quantities. That's how I know it's a rate. Okay, after 9 days, the plant was 24 feet tall. Is the length of the bean plant proportional to the number of days? So I know a proportion is 2 equal ratios. So let's see, 8 feet in 3 days. So 8 feet in 3 days. I made sure I put them in the right spot. After 9 days, okay, can I put 9 on the top? Well, this top part goes with feet, and 9 is with days. So I've got to take my days on the bottom, put my 9 down here. 24 feet. Feet is in the numerator. There we go. Now I have all my numbers plugged in the correct spot. Is it proportional? Well, remember, there's 2 ways I can do this. I can look to see, can I scale up by a number? Or I could look at my cross products. We'll do both. 3 times 3 gives me 9. 8 times 3 gives me 24. So we found that we scaled up by 3. Now, could you do your cross products? Sure. 9 times 8 is 72. 24 times 3, 72. So this one is a yes. So hopefully you're finding these questions even easier now. All right, so on the front so far, we've talked about ratios. We've talked about equivalent ratios that form a proportion. And then we just began our talk about rate. We have 2 more questions on the back, and they're going to specifically focus on unit rate and unit price. So number 6 says, Quaker oatmeal comes in 2 sizes, 22 ounces for $3.99. So there's our first rate. And 32 ounces for $5.25. That's our second rate. Which size is the better buy per ounce? All right, so whenever you see that word per ounce or per mile or per minute, you know that you're trying to find a unit rate, which in this case is a unit price because we're dealing with money. So I know I'm comparing money to ounces in this case. And I've got a smaller package that sells for $3.99, and it's 22 ounces. I'm trying to find the cost of 1 ounce. That's what I'm trying to find. Now, what we found out in the other classes, if you were here on Monday, Tuesday, is that when you write it as a rate with this fraction bar, the fraction bar means to do what? It means to divide. So $3.99 divided by the 22 ounces. And when we did this, we found that sometimes we had to round. So if you're trying this on your calculator, you might get a long amount like this. And we talked about money cannot keep going like this. Our money system only goes 2 numbers after the decimal. So we have to decide, does this stay 18 cents or does it round up to 19? So I'm going to look at that 1. That keeps it the same. So it's going to be 18 cents per 1 ounce. All right. And we're going to do the same process for our other package, which costs $5.25 for 32 ounces. So again, I want to find the price of just 1 ounce. And we talked about when you see this fraction bar, that means to divide. So $5.25 divided by 32. And when we divide it, again, I've got a long decimal. I only need 2 numbers after decimal for hundredths place. So it's either going to be 16 cents or it's going to round up to 17. Well, if I look to the right, the 4 is not enough to round it up. So it's going to stay 16 cents per 1 ounce. Now, if you want to write 16 cents with a cent sign, that's fine. Or you can write it with a decimal and a dollar. These both mean the same thing. I know we got a little bit of glare going on. I'm going to see if I can, there we go, that's better. They both mean the same thing. Just be careful. You either use the cent sign or use the decimal and the dollar sign. So the question says, what is the better buy per ounce? Remember, better buy is the one that is cheaper per ounce. So which one is cheaper per ounce, 16 or 18 cents? In this case, I hope you're saying the 16 cents is cheaper, so the 32 ounces is the better buy. Most times the bigger option will be the better buy, but not always. It's always important to do the math. Let's take a look at number 7. It's our last one. A 25-ounce bag of popcorn costs $3.80. If the unit price stays the same, how much money does a 20-ounce bag of popcorn cost? So again, I've got a rate. My rate is comparing ounces to money. So $3.80 for 25 ounces. So money and ounces is my rate. if the unit price stays the same. So they're asking me to find the unit price, which means what is the cost of one ounce, right? So remember, when you're writing it as a fraction, the fraction bar means to divide. And I'm going down to 1 ounce, right? So I want to make sure I'm dividing by 25. So 3.80, our money divided by 25. 3.80 divided by 25. Now, is it going to stay 15 cents? 0.15? Yeah, the 2 is not enough to round it up, so it stays 15 cents per 1 ounce. Okay, now the question, we didn't finish reading all the way through, but it says, how much does a 20-ounce bag of popcorn cost? Now, because the unit price is staying the same, that means every ounce costs 15 cents no matter how many ounces are in your bag. So we're not buying just 1 ounce now, we're buying how many ounces? 20 ounces. So what do you think we should do with those two numbers? We have 15 cents for 1 ounce, and we want to buy a 20-ounce bag. So what do I have to do to get from 1 to 20? I've got to multiply by 20. So I'm going to multiply my 15 cents times 20. 0.15 times 20. In this case, that gives me 3. So $3. Now, we're going to get into solving with proportions as we move along. That's another way that you could have solved this, but I want to keep this video on the shorter side. So again, we've really recapped and kind of slowed down the idea of unit price and then better buy. So if you're at home, make sure you try the practice. It is try about 15 out of the 18 and make sure you're checking your answers. Have a great day.